Hello, it's dumplet here. Here's an item on algebra. Find the coefficient of x raised to 8 of the function f of x equals x plus 1 times x plus 2 times x plus 3, so on and so forth until x plus 10. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so essentially we just want to get the term with the term x squared, and we kind of want to find the, to be specific, the numerical coefficient of this term. So we're interested in finding, if we expand this out, what's going to be the coefficient of x raised to 8. And, well, obviously we can expand that potentially, but it's going to be a very long process, so we kind of devise a plan. And in this case, at least we kind of know that if I expand it out, it's going to look something like this. So all the x's combined, it's going to give us the first term, the x raised to 10, and we're pretty sure the leading coefficient here is going to be 1, because there are no other numbers in front of the x's, so just x raised to 10. But for the rest of the terms, a little bit hard to get what will be the coefficients of, for example, the x raised to 9, x raised to 8, and so on, all the way until the constant term, which in this case is going to be pretty obvious. It's going to be 10 factorial, or just 1 times 2 times 3 up to times 10, because of the fact that all the constants are from 1 to 10. All right, now whenever we see something like this, and we have, like, for example, a, b, c for as the coefficients of, for example, some of the terms here, this is kind of related to the Vieta's formula, because we know that technically speaking, if I have a polynomial, let's just say this one equal to 0, the roots have a nice relationship with the values of a, b, and potentially all the other coefficients here. So we can kind of view this in terms of a question involving Vieta's, or we can just kind of use a little bit of knowledge in, like, the terms here. For example, we want the value of b technically here, we want the value of b. Now let's try to think, how do we make b x raised to 8? So essentially, I'm having 10 terms here, all of which are, I have 10 terms here, all of which are binomials, and I've multiplied them together. So it is kind of expected that, okay, so I want an x raised to 8 term. So I have 8 x's, and the remaining two numbers, let's just say it's m and n for now, it's going to be some of the numbers here, you can see. But obviously, m and n should come from, obviously, these numbers, 1, 2, 3, all the way up to 10. So whether we think using the Vieta's formula or just by kind of analyzing this one, if we expand this out, if we want to get the value of b, essentially what we have to do is take the sum of all possible mn, since we're taking the product of m and n here, so technically that's mn, such that m and n, so we want all possible pairs m and n that come from 1 to 10. Again, no repeats, and order doesn't matter here. So we just want to have all possible pairs. I mean, you can actually write this down. If I were to write this down, it's going to be, for example, 1 and 2, 1 and 3, all the way until 1 and 10. I can get the product of all of these and add them up. And next, we're not going to start with 2, 1, because there is already 1, 2 here. Again, order doesn't matter here. So 1, 2, and 2, 1, they're considered the same case here. So we start with 2, 3. And here, I mean, yes, it is possible to get the product of each and then add them up, but this is going to take a little bit of a long time, considering that we have a lot of terms. We have a lot of terms to add, if ever, because we're going to choose like 2 elements from 10 elements. That's like 10 choose 2. So we're essentially adding 45 products, and I mean, if you have the time for it, then good, but in most cases we wouldn't really want to spend that much of a time here. So we're going to devise like an algorithm to help us answer this one. Now, let us try to have something at the start to kind of start with our plan. For now, let's just say all possible pairs is going to come from this. Now, obviously this is not it. This is not yet it. But from this, we can kind of just eliminate those terms that we don't want. We're going to make some nice observations here. For example, if I were to expand this out, let's just say m and n are 2 numbers, just like here, the pairs of numbers. If I expand this out, it's going to be m times each and every one of these, like ones. So it's going to be 1 times 1, plus 1 times 2, plus 1 times 3, all the way until 1 times 10. And then the next number, 2, and so on. So this is going to continue. If I were to really expand this though, so essentially I will get like, okay, 1 times 1 plus 1 times 2 plus 1 times 3 all the way until 10. Then next is going to be the 2, the 3, and obviously everything from 1 to 10. Now the problem here is obviously you're going to see some of the terms that we actually don't need. For example, the duplicates 1 times 2 here, and there's another like 2 times 1 here, so that's an issue. And for example here, the one that repeats, 1 times 1, here 2 times 2, and a lot more actually. So there's a lot of terms that we don't need, but that's okay. At least we know that we can have this one first, and then just remove the things we don't need. So let us address the thing, the obvious thing first. We don't know how to. We don't want those one with the squares technically, or the 1 times 1, the 2 times 2. So we can easily do that. We know that there are 10 squares here. 1 times 1, 2 times 2, 3 times 3, all the way until 10 times 10. So I think our first plan would just to be removing all the squares. So this original thing, the product of 1 plus 2 plus 3 all the way until 10s, we're going to subtract the squares. All right, so the squares are done, and we just have one final issue here. The 1 times 10, the 10 times 1, they still are present. So for example, 2 times 10, 10 times 2, and all the other terms, for example, 6 and 8, 8 and 6. So those type of pairs that we interchange, we have to exclude those as well. But that's no problem because, well, we're pretty sure that for every pair, for example, 1, 10, the opposite, it's going to have the same value as well because, again, multiplication is commutative. So what we have to do here, since we just want to have like one pair of all of them, so to account for the repeated ones, all we have to do is just simply divide it by 2 because obviously 1, 10, and 10, 1. I can just take one of them. So I'm taking one of the 2 terms. Same for 2, 10, and 10, 2, and all the other terms that actually repeat. So for example, in this case, we can just multiply this entire thing by 1/2. And there we go. This would be the nice representation of going back for the value of b, the sum of all possible products, mn, such that mn come from this set. So just choosing 2 numbers from the set of 10 numbers over here. All right, so all we have to do now is just to evaluate this thing that we got. So it's going to be 1/2 times, I'm going to write this part as just the square of the sum of the first 10 positive integers, and then this is just the sum of squares. And here are 2 well-known closed forms of the sum of the first n, well, in this case, the sum of the first n positive integers, and the sum of the first n positive perfect squares. So the sum of the first 10 terms, 1 to 10, technically it's arithmetic sequence, but we can have this nice closed form, n times n plus 1 divided by 2. Well, obviously we're going to substitute n as 10 here, so 10 times 10 plus 1 divided by 2. This is going to give us 55. And for the sum of the first 10 squares, it's going to be this formula, n times n plus 1 times 2n plus 1 divided by 6. Again, same thing, all we have to do is just substitute the value of 10 here because there are 10 terms. And then last step is just to take the product of this one. Now in this case, this is going to give us the value of 385. So now that we have 55 and 385, we just put it back here. All we have to do is evaluate this part. Now 55 squared is 3025, and 3025 minus 385, this part is going to be equal to 2640, so 1/2 of 2640, that's going to give us the final answer of 1320. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!